This week, we'll look at one of the new calculations in MetPy 1.4, which is the sweat index. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to look at one of the new calculations in MetPy 1.4, which is the sweat index. This index combines a lot of kinematic and thermodynamic parameters into one index to figure out what's the potential of a severe storm or a tornado. Now, of course, this is an index, so it's not perfect, but it is a really helpful guideline. And it takes a lot to calculate it. We need the low-level moisture, so the 850 millibar dew point, instability, for which we use the total totals index, lower and mid-level winds, the 850 and 500 millibar winds, and we need to think about warm air advection, so we use the veering between 850 and 500 millibars. This is all incorporated together into a number that when it's between 250 and 300, severe storms can form, and when it's over 400, tornadoes can form. Now, as we'll see, the number's not perfect. We have to remember that there could be boundary interactions that are enhancing local shear around the storm that aren't captured by this, or that the 12Z sounding, if there's not a special sounding available, may not be representative of the state of the atmosphere in the later afternoon. So while it's not perfect, again, it is a pretty neat parameter. We'll look in the future at how you can calculate this on model grids, but to start off with, we're just going to do good old upper air data. I'm going to import metpy.calc as mpcalc. From datetime, we're going to import datetime. From metpy.units, we're going to import units. And pandas data frame to unit arrays helper. And from siphon.simplewebservice.wyoming, we're going to import the Wyoming upper air object. Now again, you can do this on X-rays, and that's really where we're going to see the power of it with models as it works at these different levels, but it will also work with just our united arrays. Oh, it looks like tab completion and I overrode each other there. Okay, so now let's get our sounding data. We've got lots of MetPy Mondays on dealing with sounding data, so we're not going to go too deep into that. We're going to go with an 18Z sounding from release day of this video. And let's look at station FFC. So using the Wyoming upper air object, we're going to call the request data method using our date and station. And then we're going to use the pandas data frame to unit arrays helper to attach units that are stored in df.units to that data frame, transforming it into a dictionary of united arrays. So if we look at df, we see that it is a dictionary where the keys are the names of the variables and the values are arrays with units attached. So now let's look at this new calculation, mpcalc.sweat index. If we do Shift Tab to get the quick help here, look at the doc string, we see that we take pressure, temperature, dew point, speed, direction, and vertical dimension, which defaults to 0. So let's go ahead and provide these. Data frame pressure, temperature, dew point, and since these are united arrays already, and MetPy is unit aware, it's going to handle all of the unit conversion for us. Speed and direction. And we see we get a warning about stripping of units, that's fine. And we get a number back of 291. So in fact, down in the southeast United States today, there was a severe storm potential, hence the 18Z sounding, from several locations in the southeast. If we go to BMX, we see that it's over 300. So we're in that 250 to 300 range. We might be on the lookout for severe storms. Now let's go back, still on Birmingham, but let's go to 2011, April 27th, 18Z sounding. Here the sweat index is a massive 462. This was a very severe tornado day, and we see that the sweat index shows that we expected tornadoes. So while this is a relatively simple calculation, at least on the surface, there's actually a lot that gets put into it, with the totals having many parameters in itself. So this is where MetPy is making a one-line call out of something that takes quite a while to compute if you're just trying to write it yourself. Also, with the unit-aware functionality, it really makes it easy to pass data from many sources. So this is how we work with simple one-dimensional data. We'll also, in the future, look at how we can ingest model data and calculate the sweat index across a domain using the power of X-ray. I hope that you found this useful, and I'll see you on next week's MetPy Monday.